Hello, everyone, and welcome to the Pint of Science 2021. We are here for another event on the Netherlands team, right? We started already last week some great events. Maybe I'm already a familiar face from the Pint of Science online events. I'm Guilherme, and tonight we're going to talk about plastic, the tiny ones, the microplastics. And to talk about that, I am so happy to have here with me Dr. Barbro Melgert. I hope I pronounced it right. She's an associate professor at the Department of Molecular Pharmacology at the University of Groningen, and also Dr. Francesca de Falco, which is a postdoctoral researcher at the University of Plymouth. Welcome to the Pint of Science, and to everyone at home. The beer's on the house, on your house, but cheers. Well, and I guess to start the conversation, I invite Barbro for the floor so we can kickstart our conversation on microplastics and how it's embedded in our lives.
All right. Well, thank you very much for the invitation. And I'm always happy to talk about my research, and especially the microplastics, which is a very novel subject for me. I work on lung diseases and trying to figure out what goes wrong when you get a lung disease and how we could treat it. And what is important in my research is the indoor air quality. That's something I really want to study in more detail. And why? Because we know that the levels of air pollution inside our homes are much higher than outside, especially here in the north of Holland, which has very clean air. It might be different from you guys somewhere else in the world, Brazil or Mexico or China, where the air quality is outside is unfortunately not too good. But most of the times indoor, the air quality is less than outdoors. And we spend most of our time inside, especially now. We have to be inside. So we have a lot of exposure of this air pollution inside our homes. And so what do we have inside our homes? And a lot of that is dust. You'll probably recognize this. The tops of my cupboards all look like this. And we know that the average American house, I should say, gathers around 20 kilos of dust per year. So that's a lot of stuff twirling around in the air. And then the next question is, do we breathe this in? That's something we don't know. And where does this dust come from? What is in it? Well, most of that dust is actually from textiles, from the clothes that we wear, from the curtains, from the carpets, whatever. Especially those nice, fluffy sweaters that you can buy these days. They shed fibers, and so they're floating around in the air. And most of what you see here, and maybe also from what you're wearing, now you're at home, you have an opportunity to look inside your clothes and see what your clothes are made of. But most of these clothes are made from synthetic fibers, actually. So plastic, to call it by a simpler name. And there's been some research showing that 30% of the dust that we find indoors is actually plastic. It's synthetic fibers from synthetic clothes. So from nylon, from polyester, all this stuff that makes the nice fluffy sweaters. And because these fibers are so tiny, we call them microplastics. And the definition of a microplastic actually is a piece of plastic that is smaller than 5 millimeters. And most of the fibers that are floating around in the air are smaller than that. And well, I don't have to explain to you, but microplastics are a new problem, and microplastics are everywhere. We now know that they're found on the top of the highest mountains. in the trenches of the deepest trenches of the sea. They're found in fish, and there's a lot of emphasis on microplastics in the sea. But what people usually don't realize is that these microplastics are also floating around in the air, and that we could potentially breathe them in, and that could do something to our lungs. So what I started off with in my research was, do we actually inhale these synthetic fibers that are shed from our clothes? And to understand that, you need to know something about the lungs. So I'm going to bore you with a little bit of physiology here. And so these are our lungs. And our lungs, we need them to exchange gases, right? We need to take up oxygen and we need to dispel carbon dioxide. And to do that, we have a set of tubes. And the biggest one is called the windpipe. And then that one divides into smaller airways, all the way down to the tiny little air sacs. And the air sacs are actually the units that help us breathe and exchange gases. So depending on how big the particle is that you breathe in, it ends up somewhere in our lungs. So anything over 100 micrometers gets stuck in the nose. That's what we have our nose for, except for breathing, of course, but also to filter out big things. So what is 100 micrometers? So that is a little bit bigger than a human hair or a tiny grain of sand. Mm-hmm. And anything smaller can get into your lungs. So particles that are in between 100 micrometers and 5 micrometers, those impact on the airways, and the smaller ones, of course, get deeper. But the really tiny little particles, like particles from air pollution, maybe you've heard the name before, PM2.5, PM10, that indicates the size of the particles, 2.5 micrometers and 10 micrometers. Especially those PM2.5s, those are the ones that get really deep into the lungs, into the air sacs, and might have effects there. And the same goes, of course, for microplastics. If you have tiny little pieces that are that small, they might get very deep into your lungs. So what do our lungs have to protect themselves from that? Of course, we have the cells coating the airways and the air sacs, called epithelial cells. So they keep out all the bad stuff. But you need to get rid of that again. So we have immune cells in our lungs, and these are my favorite cells. They're called macrophages. And they're called that way because macro means big and phage means eating. So they're big eaters. So they eat anything that you breathe in, basically. A bit like a PhD student on a free-for-all pizza night.
Yeah.
And so they eat those particles. And you can actually see this here. These are macrophages that were isolated from human lungs. And you can see which are the ones from people who live in a big city, because they have all these black things in there. Those are soot particles that you breathe in when you bicycle behind the big city bus that is expelling diesel gases. This is what your macrophages will look like. The macrophages will try to, yeah?
Yeah, and what is the maximum size that they get this 5 millimeter microplastics, or is that too big already for them?
That's a very good question, actually, because macrophages, they can eat really big things. I mean, a normal macrophage is around 10 to 20 micrometers, but they can eat beads that are 100 micrometers. They just grow enormously in size. But the problem, of course, with microplastics is that the macrophages can't degrade it, because plastics have been designed not to degrade. So that cell will then just die. And then another macrophage will come around and think, hey, wait a minute, there's a particle here. I need to eat this. So you might get into a perpetual mobile, actually, of cells trying to get rid of the microplastics. That's what we think. We haven't tested it yet. So I actually have a very cool movie of macrophages trying to eat nylon fibers. So we made these nylon fibers. They're red here. And we made the macrophages green. And you can see that the macrophages, they could ignore these things, or they could do something with them. From the movie, you can see they're not ignoring them.
And this is an actual movie, not an animation.
This is an actual movie. So this is we had the dish with the macrophages under a microscope for a whole night, and we took pictures every. Oops! Wait, let's go back. Play it again. Pictures every 10 minutes, and this is the end result of that. You can really see. So there are two macrophages fighting here for one nylon fiber. So these really want to do something with these fibers. And we're currently looking at and trying to see what that means for your lungs, whether these macrophages then damage the lung tissue because they're so busy trying to fight for these fibers. So what do we actually know about these fibers in lung tissue? There's been one study that has looked at whether humans have fibers in their lungs. And they use lung tissue from patients with lung cancer because they get surgery and then part of the lung is taken out. So they looked at the actual tumors, but also at the normal lung tissue that is around the tumor. And they found that actually almost all tumors and normal lung tissue contained fibers. And those were natural and synthetic fibers. But all of them contained these fibers. And these are pictures of what they found. But that's only one study. And in science, of course, one study is no proof. So that is something we want to repeat and see if we can also find this in the patients that come to our hospital here in Groningen. And there's other studies that looked at people who work in the textile industry. And one of the textile industries that is big is the nylon flocking industry. And you might think, what the heck is nylon flocking? Well, I'll tell you. Nylon flocking is, you have this velvety-like fabric that you can have in a car or like here, where you have it feels velvety. And actually that is nylon fibers glued onto a bottom fabric. And this is the fibers that they use to glue onto the fabric. And it makes it feel like velvet. So when they make this type of fabric, there's lots of these fibers floating around in the factories. And we know that people who work in these factories, 30% of them actually develop lung disease. So that's a huge amount of people that get symptoms after working with this stuff. And we now know this, so now they wear protective gear. But we don't actually know how much they breathe in, right? We don't know how many fibers are floating around there and how many they breathe in, but it would be interesting to have a look at their lungs, I would say. So since there's not a lot known about microplastics in lungs, we wanted to see what these textile microplastic fibers do on lung tissue. And to investigate this, we used a novel method called lungs in a dish, or mini lungs, as we also call them. So what are lungs in a dish? These basically are structures that we make from human or mouse lung tissue that resemble the structures that we have in our lungs. So here you can see a tube-like structure that is an airway in a dish. And here we see the grape-like structure of the air sacs, what we call an air sac in a dish. So we use this to look at the effects of microplastic fibers. Now, how do you actually get these lungs in a dish? We use either, like I said, murine tissue or human lung tissue that we get from surgeries. You process it, you release the cells from the tissue, and then you isolate these cells and put them in a tissue gel. And you give it some water and some feeding, and then these cells grow out to these mini lungs. Oh, there is a. I thought there was a question, but there wasn't. So that's the model we used. And we exposed these mini lungs to either polyester or nylon fibers that we made. And actually with help of a collaborator in Plymouth, the place where Francesca is working, he helped us produce these fibers. And we took these because most clothes are made of polyester or nylon. So those are the ones that are probably in the air most of the time.
Yeah.
And here we exposed the mini lungs to the fibers. Here you see the control condition, and you see these big tube-like things. Those are the airways. And you see tiny little, with the blue arrows indicated, air sacs. And that is what happens in our lungs too, right? The airways are big and the air sacs are really, really fine. Here we added polyester to the mix, and you see these fibers clearly. And you sort of see that there are airways, and there are also some air sacs, but it sort of looks different, right? Not completely normal. And here we added the nylon fibers, and there we actually don't see any airways anymore. And the air sacs are really, really tiny, but they're there. So we quantified this. Here we see the airways in the dish, and these are the air sacs in the dish. This is the control condition, so we get about, let's say, 80 airways in the dish. And when you add polyester, it's slightly less. And with nylon, they're almost completely gone. For the air sacs, the effect is not that dramatic, but there's a reduction as well. So what we now wondered was, okay, so we add these fibers, right? Is it the fibers themselves that cause this effect, or is something leaking from the fiber? Because we know that plastic contains a lot of plasticizers and all kinds of other stuff that will make the plastic better. And that can leak out of the fiber. So what is causing this effect? So we did an experiment in which we added the fibers like we did before in the gel, but also on top of the gel. So there was, bless you.
Thank you.
There was no direct contact with the cells. And we also washed the fibers, and then the wash we added to the mini lungs. And this is what we found. Here again, the control condition. This is the nylon fibers like we did with the cells. This is the nylon on top, and this is the nylon wash. So the conclusion here was it's something leaking from the nylon. And then I hear you thinking, so what was it then? Yeah, that's a very difficult question, I can tell you. It's still bugging us. So the first thing we did was, of course, research that wash. So what was in the wash? So if you make nylon, which is a complicated process, which I show here, but don't look too closely at it, but nylon is a polymer, so it's a long chain. And when you make it, you can make some tiny polymers can develop, and they're called cyclic nylon derivatives. And they're monomers, dimers, and trimers. So we isolated those from the wash, and then exposed our mini lungs to those monomers, dimers, trimers, or a combination of them. And you can see that there's absolutely no effect compared to the control. So this was not causing the effect. So now what? I need the help of the world, basically. Guys, help me out. I don't have a clue because we didn't find any other compounds in our wash, not in a high concentration, maybe in a very low concentration. So it could be other plasticizers. It could be bisphenols like BPA, which is a known chemical from plastic that causes lots of effects, or UV stabilizers. We're still trying to find it out. If somebody has a good suggestion.
And these fibers, are they adhering to the surface of the airways, for example? Or are they more like floating there? Because my question is actually coming from, couldn't the macrophage, when trying to dissolve the fibers, actually dissolving the tissue? My knowledge of biology is limited, so maybe it doesn't make any sense, my question.
No, it's a very good question. Yes, in theory. The only thing from our model is that we only have epithelial cells there and not the macrophages. So that's one we're going to investigate next year, is when we combine the two. But now we didn't have any macrophages there. So I think they will have a big effect on the epithelial cells, but that's not present in our current model. And we do know that the epithelial cells can grow onto the fibers, especially the polyester. They like the polyester. They grow on it. Like, oh, I like this. I'm going to just coat it. So maybe they're indeed digesting it a little bit, or trying to digest it, and that releases something. But we still haven't figured out what. Right. One more thing before I finish. The other question we wondered was, we now add the fibers when we add the cells, and then they grow out to these mini lungs. So during development of the mini lungs, but we wondered what happens if we first let the mini lungs develop and then add the fibers, because that is what adults will happen to them, because you already have lungs and then you breathe in the fibers, and is it then hurting your lungs? So we first had these mini lungs develop for 14 days, and then we added the fibers on top of the gel or the nylon wash, and then we assessed the number of mini lungs at the end. So now a bit of a complicated graph, especially when you had too many beers. So pay attention here. So we had the normal condition without fibers growing for 14 days or 21 days. And there's not much difference there, of course. And then we added the nylon from the beginning, like we did before, and then you see a reduction of the number of mini lungs after 14 days and after 21 days. But then here, we added the nylon on day 14, after the mini lungs had developed. And then you actually don't see much of an effect. So this indicated to us that it's actually developing lungs, or possibly lungs that are being repaired, that are hurt by the nylon. So in summary, exposure to nylon or polyester microfibers inhibits the mini lung development, and it's particularly the developing mini lungs that are affected. And it's something, in the case of nylon, which leaks from the nylon, and we have no clue what it is. Some kind of plasticizer, we think. And what are the implications then? We think that if you breathe in a lot of these fibers, and we still don't know how much is a lot, it might be particularly hurtful for children and fetuses, and people with a lung disease that rely on repair mechanisms in their lungs. So actually, I think the most important thing that we should do now is measure exposure. How much is floating around in houses? How much do we breathe in? And before we know anything, I would just say, be smart, keep your exposure as low as possible. So ventilate, vacuum clean, and reduce plastic use. That's what I want to end with. And of course, thank all the people who participated in this research, especially Francine on the picture here, who did the lab work.
Okay, great, thanks. And indeed, it's a complicated problem. I was thinking, maybe you can see the incidence of lung cancer after this type of fibers were introduced. But you have so many confounding factors. You have more pollution, and you have, indeed, a troublesome problem to isolate and study, but very interesting. Very interesting.
I guess it's a similar problem as with asbestos, right? It took a while before we realized that something was happening. So maybe we're also in this lag phase. I don't know. It might be that our lungs completely ignore the fibers, or that the exposure is still very low. But if we keep using plastic the way we're doing it and just trashing it, exposure will grow, because we're not getting rid of this plastic. It's not degrading.
Yeah. And I wonder, you were saying to lower your exposure, if the masks that for the last year we've been so used to using, if they are helping also with that, because I suppose they should be able to filter this size of plastics, but also another problem that you cannot really isolate.
Yeah, and the other thing is that some people ask me, so my mask is made of polyester. Should I worry now?
Well, yeah, of course, yes.
Yeah, so I don't know the answer to that. I guess it all depends on the type of fabric, right? If you have a fabric that doesn't shed any fibers, I think you will be protected more. But if you have a fabric that sheds lots of fibers, you might be endangering yourself. But then again, coronavirus is also not a very nice infection. So it's lots of things you have to weigh in this case. So jury's still out there.
Yes. We do have a question from chat. Maybe it's a little out there. It's from Enrique, and he asks, I would like to do a study on microplastics focused on agriculture and soils. How could I start, or what would my starting point be? And then he thanks.
That's an interesting one. Well, I would start thinking, so what is your research question? What do you want to know? What do you want to know, if these microplastics are taken up by plants, or if they affect plant growth, or what is it that you want to know, and what do you think might be a problem? And that would be my starting point.
Yeah, great research questions right there. And I don't know if Francesca, you have anything to add on to that also, I guess we're also gonna be hearing from your side of the story soon.
Actually, I have a couple of questions to Barbro about the presentation. I was wondering, what type of fibers do you use? I mean, were there commercial fabrics or standard fabrics?
Oh, that actually, we use a thread, which is made by Goodfellows, which is a very standardized polyester and nylon, and we cut it into these very specific sizes, like Matthew Cole told us how to do it. And I didn't show those results, we also used fabrics that we could just buy in a fabric store. So we went to the local fabric store and got ourselves 100% polyester and 100% nylon fabric in the colors red and white, because maybe the color has something to do with the effect. And we cut that also in very tiny little pieces. And we found that those fabrics and those fibers from those fabric had the exact same effect as the nylon and polyester from Goodfellows. But now we get to the interesting part. I got a Belgium is using, for coronavirus testing, they're using these swabs. And these swabs are made of nylon. And what they noticed in Belgium is that people who were being swabbed with those swabs, there were particles or fibers left behind in the noses of people, and they were worrying about that. So I tested some of those swabs for them, and those swabs are made of nylon. It's flocked material that they use for the swabs, and we tested that nylon, and it didn't do anything. The mini lungs were just growing happily as in the control condition.
At least a good news.
Good news, indeed.
Yeah, good news for the people in Belgium. But I was like, so what kind of nylon is this? So I sent it to the distributor and asked him what kind of nylon is, because it's apparently not a standard something from nylon. There's nylon and nylon. So yeah.
Did you get an answer from them?
No, not yet. I just sent them the question last week. So it's all, I mean, this is very recent, right?
Secret. We never know.
I was wondering about what Barbro said about what types of additives or plasticizers, other things can be inside the nylon fibers, and what I've seen in my experience with the textile companies, that is really different, really difficult to get the full story of a fabric. So because textiles are really treated in a lot of ways, so they have dyes, chemical additives, finishes, bleaching compounds, a lot of things. So and it's difficult to get this information, or even from the manufacturers. So the problem for our scientists, especially for what Barbro do, is try to understand which compounds can be really toxic, because it's difficult to identify them.
Yeah, exactly. That's exactly the problem we're having now, because we actually contacted Goodfellows, who made this very standard nylon and polyester, and asked them, so what is in there? Because something is leaking out. And they said, there's nothing in there. We don't add anything. I said, yeah, right.
Sure.
Don't believe you.
Yeah, we have a question from YouTube here that perhaps is interesting. Is from Maltagliati. I hope I pronounced that correctly. And they say, I read that they found microplastics in placenta of unborn babies. Does this depend on what the mother is eating, drinking, or breathing?
I think so, yes. But what the main source of the microplastics in the placenta is, we don't know, right? Because we don't know how much a mother eats microplastics or breathes. And all those data is not out there yet. So I think the only way for those microplastics to end up in the placenta is either through eating or breathing, and then being taken up into the body and then getting all the way down to the placenta. So yes, I think it depends on what the mother eats and drinks or breathes.
Yeah, so and it actually gets into the system, right? It doesn't get stuck somewhere.
Yeah, so that's the scary part, right? So that means that whatever we eat or breathe in gets transported across those epithelial linings that are designed to keep things out. The macrophages that are designed to eat stuff there, they don't do that good enough, and then stuff gets into your body.
Yeah, at least the blood-brain barrier is quite difficult to pass, but imagine if we start getting plastics there also. That
don't count your chickens there, because I know air pollution gets into the brain, and those particles can be of a similar size. And there are actually some researchers in Holland looking at microplastics in the brain. So we might have an answer for you in 2 or 3 years, whether you have to worry or not.
Yeah. Well, yeah, the ship has sailed for 30 years now already. But yeah, thanks a lot. I don't know if, people can keep asking questions and we keep addressing, but perhaps it's time to now hear from Francesca and how we get these particles in the first place, I suppose, in our environment.
Yeah. Okay, can you see everybody my presentation? You're never
it's
sure?
Perfect. Yeah, it's
okay.
Perfect.
Okay, so I will talk to you about how microplastics can be released from our clothes during everyday use and activities like washing and wearing. So okay, let's start first to try to understand why clothes are considered a problem in the scenario of microplastic pollution. So the first article that correlated the presence of microplastics of fibrous shape in sediments collected worldwide with the percentage of synthetic textiles used in the fashion industry dates back to the 2011. But from there, we have learned a lot of new things. And now we know that this type of pollutants are not found only in the aquatic ecosystems like seas and oceans and other freshwater systems like river and lakes, but can be also found in soil and in dry and wet atmospheric deposition. So according to some recent estimations, the washing of synthetic textiles contributes by 35% to the global release of primary microplastics to the oceans. And so synthetic textiles as tires represent the main sources of microplastic pollution. But actually the problem is not only related to synthetic fibers, because in the environment have been found also natural fibers like cotton or wool fibers, and also artificial ones. Artificial fibers are fibers that are of natural origin, but then are modified like regenerated cellulose. So let's keep it simple: rayon, modal, lyocell, this type of fibers. So I prefer to use the term microfibers, indicating all type of fibers, so natural, artificial, synthetics, and all with dimensions in less than 5 millimeters. So why this problem is so important to us? It's important because we actually produce and consume a huge quantities of fibers. In 2019, the global fiber production reached 111 million metric tons, and we have polyester in pole position, followed by cotton. And as you can see from this graph here below, this is a trend that has been constantly increasing since the 70s, and is predicted to even increase more in the next 10 years. So let's see some numbers and try to understand how many microplastics are actually released from clothes. So I'll show you the results of a study that has been done in collaboration between my previous employer, that was the National Research Council of Italy. And we tested commercial garments, so garments that were purchased in normal shops. And here you can see 3 garments made of 100% polyester. And we chose these garments because they all had different textile parameters. So a fabric can have a woven structure or a knitted ones, and the yarns that are interlaced in the structure can be made of continuous filaments that are fibers or of indefinite length, or can also be made of short staple fibers, like as the name says, are fibers with a short definite length. And the yarns can have no twist, can have a low, moderate, or high twist. And fabrics have also an hairiness, that is the number of fibers that protrude from the core yarn. And according to the market offer, we also tested a garment that was a blend of polyester and cotton, because polyester is often blended with cotton. And this garment had a knitted structure, yarns made of short staple fibers, low twist, high hairiness. And in these scanning electron micrographs here, you can see the really smooth and cylindrical polyester fibers, and this one with a twisted ribbon shape are the cotton ones. So what did we do with these commercial clothes? We wash them separately in a commercial washing machine. We use a washing program for synthetics using a commercial liquid detergent. And we filtered all the wastewater coming from these washings, and the whole wastewater was collected and underwent a multi-step filtration procedure. So we had the filters with decreasing pore size, starting from 400 micron to 5 micron. And these filters were weighted before and after the filtration to obtain a quantity in milligrams of microfibers released. And after these filters underwent some analysis through microscopy, and we calculated the average dimensions of the microfibers released, and through a simple conversion formula, we obtained the number of microfibers released per gram of washed fabrics. After, we did something very unconventional, because we asked some volunteers to wear these garments. We closed this volunteer in a room. This was let's say, a clean room, decontaminated from all types of other fibers contamination, cleaned very thoroughly to avoid any dust or any type of other contamination. And these volunteers performed very patiently, I have to say, for 20 minutes, a routine of movements. And these movements were chosen to simulate more or less our everyday activities. And in this room, we placed some passive samplers that were dampened filter papers inside Petri dishes. We collected these filters and analyzed them by optical and FTIR microscopy. And through some simple formulas, we obtain the number of microfibers released per gram of worn fabric. So let's see the numbers, let's see the results of this analysis. So the numbers of microfibers released to water per gram of washed fabrics ranged from, let's say, 400 to 4,000, depending on the garment type. Instead, in the wearing test, the numbers were of just few fibers to 400. And what these graphs show us is that the garment that released less was these green blues. And why was that? Well, these green blues had a very compact textile structure, had yarns made of continuous filaments, very highly twisted with low hairiness. So this very compact structure made for the fibers more difficult to slip away from the fabric during the mechanical stresses. When we go for garments that had the more loose textile structures, like a knitted one with yarns made of short staple fibers, with no twist, low, high hairiness, we had increase in the microfibers released. And the garments that released more, actually the greatest numbers in both types of tests, was this sweater with this mixed composition of polyester cotton. So we made some additional analysis on the fibers released by this garment, and the fibers collected on the filters from the washing test underwent thermal gravimetrical analysis that allowed to determine that the 80% of the microfibers released by these garments were actually cotton ones. And similarly, also the analysis by FTIR microscopy of the fibers released by these garments during the wearing test, where the 90% were composed by cotton. So cotton fibers are released more easily than the synthetic ones.
So if I may have a question that
yes, sure.
Because it seems, I don't know how accurate the pictures are, if these are the clothes that were used, because it seems that the one that released the most is the type of clothing that simply has more fiber in it. It's like a heavier blouse than the other ones. If we would go to an extreme, an example like underwear, there is less fiber in total on the piece of cloth than a pullover clothing. So I don't know if this is
no, because these numbers were normalized for the weight of the garment.
Now I can see it.
It's here. They were normalized, so they're not dependent on the grams.
Okay, perfect. And there's perhaps one related question from YouTube already that asks if you use a different temperature and rotation on the washing cycle to see if that affected the release of these fibers.
Well, in this study, no, because the purpose of this study was to try to single out the influence of the textile parameters. So we washed all the garments in the same condition, but I've performed other studies. I will show briefly some results in the following slides, where, yeah, there is an effect also of these other parameters, but not for this study.
No, thanks.
Okay, so let's move into microfiber dimensions released during this test. Hopefully also the one in the air are much greater than the critical dimensions mentioned by Barbro. So maybe it's partially good news. And in general, the average length of microfibers released by these garments was greater in the air release test compared to the one in the washing test. So for the air test, we had the average length around 1 millimeters, while in the washing test, we had the average length from 600 to almost 900 micrometers. But also in both tests, some microfibers of, let's say, 50, 80 microns were detected. And only these garments that released the lowest quantity of microfibers had an opposite trend. So actually, shorter fibers were released to air compared to the washings. So at the end, we tried to scale up the results that we obtained by this study. And we made some assumptions. So we consider one person what type of laundry can do in a year of his polyester garments. And we also considered more or less the wearing activity of one person per year wearing only polyester garments. So we scaled up this data, and we obtained that one person per year can release up to 300 millions of polyester microfibers to water by simply washing their polyester clothes, or can release 1 billion of polyester microfibers to air simply by wearing polyester clothes. So these are really impressive numbers that should call for more research and for the identification of effective mitigation actions. So the take-home message and further steps of the results is that there are some textile features that can influence in a positive way the release of microfibers. And this should be considered. There should be some indications for the textile industry to apply some mitigation actions already at the textile design and production levels. And we have seen that microfibers released to both water and air are of similar order of magnitude. So we cannot implement mitigation actions only at the laundry level, but we have to go up a bit in the production cycle and find other solutions that can also prevent the release of microfibers to air during wearing. And of course, we need more studies on the release of microfibers to air and potential impact, basically Barbro's work. And these, of course, have caused an underestimation of microfiber pollution because up to now, all the estimations were based only on washing processes of textiles, not on the other activities like wearing and potentially also drying. And finally, this fact that cotton fabrics release this huge amount of fibers calls for more research because we need to consider also other types of fibers, not only synthetic ones, as pollutants, because they have been found in the environment. So we need more studies of natural and artificial fibers because they clearly are still persistent in the environment, and we need to understand why. So just the last couple of slides, I would like to leave you with some positive message about some mitigation actions that we can implement and possibly study in our research work. And of course, this is a very complex problem, the one of microfiber pollution. We cannot go for only one solution, but we need to act at different levels. So we need to act at textile design and production, at laundry level, and at wastewater treatment. So I will briefly show you some possibilities for these two levels because the third is out of my expertise. And about textile design and production, well, as we have seen from the work I showed you, there are some textile parameters that can influence the microfiber release and give some guidance for textile design. But there are also another possibilities, that is the development of innovative finishing treatments. This is some works that I've done during my PhD, and of course it needs more studies, but basically the idea was to apply a very thin layer on the fabric surface that could act as a protective coating during washing and potentially also wearing of textiles. And these treatments were based, one on the use of pectin, that is a natural polysaccharide, so something completely eco-sustainable, easily obtainable from agricultural and food industry waste. And this pectin was chemically grafted on the polyamide 6,6 fabric. And another treatment I developed was based on the application of biodegradable polymers, again on polyamide 6,6 fabrics, and using a more complicated technique that is an electrofluidodynamic method. And both types of treatments show that some very encouraging results, because they were able to reduce microfiber release during washing of more than 80%. But of course, that's where some very preliminary stage and more research needs to be done. So finally, what can we do also during our laundry, something we can easily do by ourselves? First of all, the detergent has an effect on the release of microfibers. In general, when you use a detergent, it increases microfibers release comparing to washing with only water. And in particular, powder detergent are quite critical, because these products had some inorganic compounds that are not soluble in water. So you have this powder that causes friction on fabric surface, and in this way it favors the release of microfibers. We also have some positive effect of some washing additives like the softener, that it seems to decrease of more than 35% the release of microfibers, and this is because the main duty of a softener is to reduce the friction on the fabric surface. And related to the previous question, of course, when you wash with more stressful parameters like higher temperature, washing time, and very high centrifuge rotation speed, the stress is worse from the fabric, so they release more fibers. And another thing that should be taken into account is the use and development of some capturing devices, particularly filtration system, ideally already built in washing machines. And I would like to thank you for your attention, and to the organizer for inviting me, and please feel free to ask me any question. Thank you again.
Oh, thank you, Francesca. Very interesting. And some practical tips that we can start today, because the weekend was busy, and of course I didn't do my laundry, so I can start today addressing that. Oh, we seem to have a connection issue. Okay, now we're back. Great. And yeah, interesting things. And we have several questions actually from both YouTube and Facebook. So let's see. We have one from Injezu. So thank you for your presentation. I am wondering if you have investigated the effects of using drying machine after the washing machine on the release of the microfibers.
Well, no. Because the beginning my research was in Italy, and in Italy we don't use dry machines so much, so it was not
it's good weather.
It's good weather, so it was something that was not on our list of priority. But I think there are a couple of works in the scientific literature that have investigated, and well, in the UK I have used a drying machine, and I've seen all the fibers that are in the filter. So definitely it will cause a high release in the air. So, but there are a couple of articles in the literature that can be looked.
Yeah, and I can imagine, because you are tumbling, and it's a high temperature. You have the clothes rinsing against themselves also without any kind of lubrication, without the water or the softener. So I can imagine it releases a lot indeed. Yeah. And we have another one from Enrique. Yeah, of course.
Yeah, sorry, you're talking about the softener. I was very practical question. Sorry about that. But the softener is usually added at the end of the cycle, right? After the washing. So should we add the softener earlier then?
These results that I was referring were some laboratory simulation of a washing. So in that type of experiments, the softener was added for the whole length of the washing, because it was done in a washing machine, in a laboratory simulator. Yeah, this is tricky because this is something that still has to be tested at washing real level. But the fact that the property of the softener to act as a lubricant is definitely something that should be considered. And yeah, maybe, well, for this type of investigation, you also need maybe some support from the detergent manufacturers to try to, because maybe we will have to switch a bit our laundry habits to mitigate the release.
Interesting. Well,
No, it's very,
follow
very
that
pertinent
closely.
question. Yeah, I didn't
Yes,
think about
exactly,
it. Yeah,
because
it goes on the end, of course. Yeah.
yeah. So yeah, I was thinking, how can I make things better? The small little steps we can do ourselves, right?
Yeah.
And related to that, there's a question from Vinicius. He says, interesting talk. Old clothes, for example, even if they are made with continuous fibers, according to use of time and washing, would they break up more and go back a step as if they were not continuous fibers? I suppose that's what he means.
Yeah, this is a really good question. And actually, this fact is still very debating, because up to now, the only research works that have been performed of this type have only washed clothes up to 10 washing cycles. And what this type of investigation show that during these 10 cycles, you reach a plateau. So let's say after 4 or 5 cycles, the number of microfibers released are more or less the same. On the other hand, there are other works that have performed the test using really washing loads. So they went to some houses and collect their laundry. So they washed these clothes that were not new, but it was difficult to say their age, but they still released a lot of fibers. So what we don't know now is, okay, yes, after 4 or 5 washing cycles, you can have a decrease in the release, maybe because most of the fibers are residues for the manufacturing process. But the other things that need to be investigated is that if there is a threshold where, okay, you have this decreasing trend, but after the clothes become so old that their fabric strength is not as the beginning.
Yeah.
So maybe you can start releasing again. But we don't have any data now because no one has been washing clothes. You know, you have, when you do this type of experiments, actually you do a washing machine. So during my PhD, everybody was taking fun of me because actually I was washing clothes. And so for this type of investigation, you have to keep washing. And, it requires times and it has a cost. And but yeah, it's something that from my side, I really interesting to know more about this.
Yeah, but I can imagine. Yeah.
Oh, sorry.
Go,
if we take the dryer as an example, so from personal experience, I would say, so we do use the dryer in Holland because we don't have that nice weather here. I know that I don't really see less lint in the dryer with the clothes that we're using for a very long time. So that would suggest, at least during the drying stage, that they keep on releasing. I know some clothes release more lint during the drying cycle than others, like those nice fluffy polyester sweaters, etc. They release a lot, and they keep releasing it all the time, also when they're like 4 or 5 years old. So that doesn't bode well, I guess, for older clothes.
It seems to be, as Francesca suggest that the fibers that are loose wash out, but then the ones that are strong for manufacturing, they are not strong anymore and they are breaking up. So I have plenty of old clothes that I don't use with holes on them. So Francesca, if you want them, you can have a project with my old clothes. Because I imagine it's also one of these ideas is to avoid buying new clothes. So I guess people try to use the clothes for longer, but maybe at some point it's better to renew. It's something to see. We have lots of other questions. People are very interested. We have one that's from that's a difficult name. Let's see if I can not make a shame of myself. Akshaya. Okay, Enrique can be. Yeah. So any recommendations on a textbook? Well, okay. Okay, Akshaya. Okay. So that's more for Barbro, but I guess it goes for everything.
Definitely.
Thank you for the lovely presentation. I would say that was for both of them also. I was wondering if people have any generic susceptibility towards microplastics like house dust mites and in airway diseases such as asthma.
Well, that is a very good question. Very interesting. We don't know. That actually is the short answer because this is such a new topic. We haven't really studied it yet, but it's part of the work we're going to do in the coming years, is to see if being exposed to microplastics make you more susceptible to developing asthma against, for instance, house dust mite. You could also think that plastics tend to bind things, right? If you have a plastic container, you put it in the dishwasher with pasta sauce, that the plastic container gets all red because it just attaches stuff. So that might also happen with house dust mite. It might attach to the microplastic and make you asthmatic more easily. But those are all hypotheses. We haven't tested it yet, but it's something that we're going to look at. So I think it's a very, very good question, and that I'd like to answer, actually.
It's very interesting to understand a little bit, right? It's part of figuring out the impact that all of these have in our daily lives. So thank you. And perhaps since I even mentioned Enrique's name again, we can finish with this one.
Yeah.
It's a little bit more generic for all of us and Enrique to study a little bit more. Any recommendation on a textbook that can guide me on and strengthen what have been spoken today? It has been very interesting listening to you. Spanish is my mother tongue, and these are not topics usually discussed in classrooms. That's very true. We are all learning here today. And it says, greetings from Guatemala. Hello, Guatemala.
Ooh.
Well,
Do you know any, Francesca?
Yeah.
I don't.
Well, if I may suggest, is look for those two lovely women on Google Scholar and start reading from them.
Absolutely. I mean, papers, of course, not just on Google, but also bioarchives, MedArchives that posts the newest research. I guess Francesca has a lot of papers on this already, so that would be a good one to start.
Yeah, I cannot think of a particular textbook because this is such a new topic. So, most of the textbooks up to now are on microplastic pollution more in general. So something specific on textile, I don't think we have yet. But on Google Scholar, on other browsers, I think you can easily find some research articles. I think also some reviews articles are coming up. So in any case, there is also ResearchGate if you don't have access to some of this.
Exactly. You can always send authors an email.
Yeah.
True. Yeah, especially these kind of topics. People are always eager to spread awareness, and make everybody understand. And yeah, on that note, we have perhaps one final question now from Nicoloso. Thank you for raising such a topical matter. And then he wonders, if cotton turned out to be so bad for the release of microfibers, what fiber would it better to buy? And when you don't buy secondhand. So also a question for anybody trying to make a company to manufacturing clothes, I guess, right? So where should they aim for?
Yeah, this is really difficult. A lot of people keep asking me what type of clothes should I buy, and well, actually, I cannot give any suggestion because this is really new topic, and this fact that we have been finding also natural or cellulosic based in general fibers in the environment indicates that even if they are natural, they undergo some chemical treatments during their manufacturing that alters their chemical structure. For example, cellulose, after it is mercerized and bleaching, it has a different structure from the one found in nature. So maybe this could be a cause that why it's still persistent in the environment. And the second problem is that you have a lot of additives, dyes, and other finishes that completely alter the structure of these fabrics. In the end, you still find them in the environment. So as the textile industry is currently, it's difficult to tell you buy a type of fibers because actually all type of fibers are coming up in the environment. What I can advise is to change the way we buy clothes because now we are in the fast fashion area. So we are compulsively buying new clothes and most of the time these clothes are of very bad quality. So you can see by your naked eye that they release fibers. So my suggestion is try to shift from fast fashion to slow fashion. So buy less, try to buy things that are of better quality and ask for mitigation actions from the textile industry because this is a problem we cannot solve without all the manufacturers involved.
Yeah, indeed, very difficult to figure out. But maybe we'll get there with the help of you. We can understand a little bit more. And it's also, the tips are invaluable on how to reduce that at home now already. So that's great to hear. And I think with that, I would like to thank you both again so much for being here and being available to share your knowledge and your studies with us. Everyone that has been watching on Facebook and on YouTube and the team here tonight, thank you so much. Stay tuned. We have plenty of more interesting events coming up this week. Today was the Groningen team together with the Green Office of Groningen trying to spread awareness on this plastic issue. And tomorrow we're going to have the team of Leiden presenting video games and bioengineering. And I'm pretty sure it's going to be just as great as today was and as last week was. If you guys missed any events from last week, they are all on YouTube for you to watch. And thank you, everyone, and have a lovely evening and a lovely week. Bye-bye.
Thank you. Bye.
Bye, guys. Thank you.
Bye-bye.